The broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome. My name's Jason DeRuver. We're just going to wait another minute before we get started, or two, just to see the attendees are still climbing up. Once that levels out, we'll go ahead and get started.
Introduce myself more, and you introduce yourself, or you do that, and then.
All right, welcome to the Local Agency Outreach Working Group's bi-monthly webinar on bridge maintenance. My name is Jason DeRuver. I'm the co-chair of the group. Also, we have Travis Kinney, the other co-chair. He's on mute right now, though. This month, we're going to be discussing concrete bridge repairs for structures, including decks, superstructure, and substructure. We have two experts in concrete repair from the state of Michigan, Jacob Creisher and Tom Ranck. They work in the statewide bridge support unit, directing maintenance forces across the state of Michigan. And with that being said, if you have any questions, go ahead and ask them in the question box or the chat box, and I'll be monitoring that. And when there's questions that need discussion, I'll chime in and have Jacob and Tom address those. With that being said, go ahead and start your presentation. Thank you.
Thanks, Jason. My name's Jacob Creisher. I'm the engineer manager of the statewide bridge unit. I guess a little bit of history I've had after I graduated from college. I had 20 years of experience in bridge design as a consultant, and then I've been in 8 years at MDOT and only 2 years as an engineer manager.
Yep, I'm Tom Ranck. I work for Jacob. I'm a structures engineer. Got about 4 years of experience now.
We'll go ahead and start. I said this is about bridge deck patching. I do want to give a quick little overview of our unit itself, how we run. Obviously, the state of Michigan, we have almost under 6,000 bridges. They're broken up into in each region. There's 58 we call big bridge. Those are unique bridges like the tied arches or trusses, but they're also big span bridges that are over 1,000 square feet. We have 12 movable bridges, and then we've got, because we're in Michigan there, we've got 2 bridges that cross into Canada, and then we have the Mackinac. So we have 3 different bridge authorities that are in charge of their bridges, but we do help with them as much as we can. Our maintenance forces, we have our state as shown in there is broken up into 7 regions. You can see that then we have 14. Each region has a region bridge engineer and we communicate with them throughout the year. So we're always talking to those 7 bridge engineers. Then we have 14 crews throughout the state, as as shown on there. Some areas have 4, some only have 1. It just depends on how they organize their region there. And then we have 3 what we call central office ones, and we have a statewide steel bridge, which mainly do steel bridges, whether it's high load hits or any type of steel maintenance that needs to be done on these bridges. Our units, the statewide region support units, so we do most of the preservation and maintenance in the state. And then we have a statewide reach all where we have 3 reach alls with guys that help, and then the Port Huron has another reach all too. So these are the maintenance activities that we do. I said we do bridge cleaning, siling, healer, sealer, epoxy, pressure relief joints. Those are all things that we have our crews do, and we help as much as possible with them on alignment. This is kind of a disclaimer that we put on here. Most of the stuff is about MDOT, maintenance of our own forces. Make sure if you guys end up doing anything to a bridge deck, consult with your local bridge engineer on any structural work. So, but we're going to try to show you as much how easy it can be done, and it's just a matter of getting the guys out there wanting to do the work here and all stuff. So this is the agenda. I want to kind of talk about the causes of concrete deterioration, and we'll talk a little bit about some deck patch scoping on how we do it. Then we will talk about the equipment, and then obviously the patch preparation is very important. It's one of the most key things to a good patch. Then we'll talk a little bit of some material selection that you can do based on the type of patch that you get to do, patch installation, curing, and then we have some last preservation practices that we'll show of what we do quite a bit. So the causes of deterioration. These are the 3 main reasons why concrete deteriorates. Obviously, you have steel reinforcement, corrosion, chloride and intrusion into the concrete, and then the structural defects that we have on here. So as you can see, I got a picture of a deck section. It's the actual partial because a lot of times in our decks we have 2 mats of steel, but this is like the top part of it. You have a concrete. Oh, sorry about that. Yeah, you have a concrete cover, on there. There you got your rebar is on there. Most concretes that we have today are permeable, so that allows water and salt to filter in through the pores of the concrete. And then obviously when the reinforcement reacts with the chloride, it causes the bar to kind of swell, or I call internal pressure. And then with this pressure, it creates cracking. And once cracking happens, then it takes a matter of time before the actual concrete falls, and then it could fail. So this next thing is as a slide. It's kind of cool. It starts off where 0 is 5 to 20 some years, where all the filtration of the chlorides get in there. You can see the reinforcement starting to corrode it, and then once you get your first crack, then it starts. You can see how exponential rise where it fails. So I always like that slide to show on there. This is kind of a situation we had out in the field where we had a partial deck. You could see like a crack line along the center, right along there. So it was kind of a cool picture, that we had on there. Chloride intrusion, the second one there. Obviously, you have the snow and ice, especially in the area that we're at in Michigan. We have snow and ice that are on our bridge decks, and inside those, they start to melt. And as they melt, they filter into the concrete. And if you remember, concrete has air entrainment out there, for allow for water to get in those bubbles there, and when they freeze, they expand, and that's the part of the deterioration that happens with our concrete. So this is not really the steel, but this is more of the concrete itself. So that's why I said the steel does its own corrosion. This helps degrade the concrete when we on the outer deck surface. And then the last thing I call it structural defects. A lot of it has to do with when the concrete's in its plastic stage, which is during the curing process. If it's not cured properly, you start seeing cracks. You could also have cracks part of the construction where whether the bearing of the actual concrete fails because it's not compacted, shoring. These are all things that start cracks that you don't quite see. And then obviously you can also have some incorrect design loads where you have forces that you weren't inspecting, on parts of the deck that, especially like on a skew or where you don't have additional reinforcement along the fan those bars. So our first thing when we go out and do a deck patch scoping, or we have something there, I always tell the guys, let's do our homework. A lot of times, we have access to, I guess you'd say, like it's not really a spreadsheet, but a program that, we can see what the history of the bridge. So a lot of times we like to look at, existing plans to see if did it have a shallow overlay? Did we have a deep overlay? Is there, if they had previous patches failed and all stuff. So a lot of stuff we want to do that prior to going out to the site, because when we go out to the site, we're going to visually see the top, and then we always like to look at the bottom. But if we know the history, it makes it easier. Because like for example, if I believe on this bridge deck here, you look at the bridge deck, it looks pretty bad. Actually, I think if I recall on this picture, it was only the top surface where the shallow overlay debonded from the concrete. So it was really kind of more of a shallow. The bottom of the deck was actually pretty good, but you would never know that without getting an idea if it had a shallow overlay at first. So because a lot of times when we go out to the deck patch, we really don't know what type of patching we're going to do. So once we get out there, we visually see the bottom in the top. We then go ahead and start sounding it. And a lot of the times with the sounding, we use sounding rod or chipping, or a chain drag, and we kind of make good squares. We use paint. You can see some of in the picture there. You have a couple of spalls like right here, but then we try to go outside of the limits there, relatively 3 to 4 or 5 inches outside of the spalled area or the delaminated area, and map out our bad concrete. So this is the concrete that we're expecting, them to remove. So this is kind of like a little diagram that we have. You can see that in the big square there's like 3 or 4 deteriorated areas, and we try to group them together, to make it, one nice saw cut around there. If you have something less than a foot or a foot and a half, we like to try to add those together, because that area is where it could fracture and break, maybe, not this year or a few years later. So, trying to make it, nice, good, solid concrete all the way around. We saw cut all of our perimeters, on there. So, and then it comes to the patching. There's 3 types of patching that we consider. And again, you won't know that until you start hammering. Once we start jackhammering, you start getting an idea. We have what's called a shallow patch, where, you take out the first 2-3 inches, and after that, the concrete is sound. So, there's no reason to go any farther. We do have material that we can actually do concrete, which Tom will talk about later. If it's a deep one, we try to go below the first mat of steel of the rebar. And so that's another type of patches that we call it a deep patch. And then if the bottom and the top is bad and it's totally out, then it's considered a full depth, patch there. So those are how we kind of dictate our 3 patches. And this is kind of visual of it. You can see the shallow patch. We barely see the rebar. Then you got the deep patch where you see the first matter reinforcement, and then obviously the full depth, you can see right through the bridge. So that's pretty much how we scope our bridges. Next thing, deck patch equipment. Now, yes.
Hey, Jacob, I have a question for you.
Okay.
When you're scoping deck patching, how much of the deck, what percentage of the deck can be delaminated before you think about switching to some type of overlay instead of just deck patching?
Well, and I think in Michigan we have a matrix that I think it's a certain, 15, 12% or something. I don't remember what it is on there. That's a lot of the times the region bridge engineer will kind of look at that and make that decision. Now, unfortunately, we've had some where the delamination is excessive, and we have other resources that we do some that we could possibly do, especially like an epoxy, thin epoxy overlay, or not thin epoxy overlay, a shallow overlay. We could do a deck injection. So
yeah, and I mean, if this is a local area, it also depends what your crew is capable. If they go out there and it seems to really escalate in a hurry, you might want to step back, fix what you have and reevaluate the situation. You don't want it to turn into, maybe it didn't seem like the whole thing was delaminated at first when you're scoping, and then it quickly escalated where the quantities are really taking off. Step back, figure out maybe this isn't the right approach. Maybe we should do something else that will be more beneficial. So hope that answers the question.
So it sounds like anything above 15%, you should think about doing some other type of repair other than just deck patch.
Yeah, but I mean, because the hydro is a very expensive operation. But yeah, once you start getting to a certain degree of that, I mean, it's hard because we actually were out of deck where just recently they actually put 22 cubic yards of concrete, and technically it was well over 15-20%, but the region bridge engineer says that I don't have the money to hydro. I can, he was able to shut down the road for 2 weeks to do a patch, but for us, our standpoint is that seems a lot on the maintenance crew to do that. But when there was no other option, they wanted to do that because they were coming in with an HMA later on, so sometimes you don't have a way of getting out of it. But really, if proactively, once they start doing patching, if they notice that it's going to escalate, it's better to do another method, but
okay.
So
it's just a guide, 15%, just has a lot of other factors too. Okay.
Yeah, there's a lot. I mean, it's like now, like like I said, just that road wasn't over. It could be closed for 2 weeks, not a big deal. But if it was a freeway, yeah, I mean, at that point, I don't think you can shut that down for that long a time. So, is that all? That's it right so far?
Yes.
Okay.
Thank you.
Now we'll get to the deck patch equipment. Most of the stuff on the left side there, you need a concrete saw, a jackhammer, air compressor, sandblaster, and concrete finishing equipment. Those are all things that are easy to get and not as expensive. The air compressor is probably your most expensive, and that you can rent. So this is kind of what we use for our saw. It's a walk behind, so it's by Husqvarna. So I mean, it's probably what $3,000-$4,000, $5,000.
Yeah, there's all different makes and models. This would be one of the better tools you can use. It is possible and achievable with a larger handheld, like a steel or Husqvarna concrete saw, like a 14-inch blade. And it is possible too with a handheld angle grinder with a concrete blade. That would be the most time consuming, but the most cost effective.
So you're only trying to do a 1-inch cut anyway. So this one right here, I'll show like a picture later on there, but that's kind of what we have, here for our state forces. This is the jackhammer. These are saw layers. So you can see that, the ones on the left are the actual hammers. We typically use 60 pounds. Some guys get away with 90 pounds, even though we tried to, make sure that they know what they're doing, because you can do a lot of damage with it. And then the stuff here on the right, especially in the middle, is a rivet buster. So that's a 20-pound. And the three here are a lot more vertical, but those are kind of what it looks like. You can see, as air compressed goes in there, and this the trigger here, and you hold there, and you normally have whatever you want to bit on the end there, whether you want a flat or a pointed one. So
it really depends on the type of deterioration. If it's a very shallow patch, for example, you might only want to go in there with the small chipping hammers and scale the area, versus if it's going to be a deep 2 to 3 to 4 inch patch, you're going to want a bigger hammer to make quicker work or quicker time. So,
and then this is the this is 185 CFM. This could handle 3 jackhammers. So it's a toll behind. This one here, I said buying brand new is, pretty much $25,000. So that's your most expensive cost, but you can rent, and they do, you can rent these from several different manufacturers out there. So, so that's the air compressor that you need for run the pretty much jackhammers, your air compressed air to clean the, and then also really you could use it for the blaster. So this is the Clemco. These are our sandblasters. This is a walk behind. You got, like I said, you got a hood, so you could get a kit for, I think, around $5,000 to $6,000. So, again, this is something that, you need to do the deck patch, because you have to sandblast either the reinforcement or the edges of the concrete, and I'll explain that later on, so for a better bonding, so that's what we have here is we use these Clemcos. A lot of our units, all of our bridge crews have these in their trucks there. This right here, so we'll talk a little bit about patch preparation. Obviously, once you've sound the deck, you know what it is. I like to see better squares. I mean, this is a little bit on an angle. I mean, you can get away with, an obtuse angle, but if you had an acute angle or something that's where it's closer, this would spall this area, there. So, like I said, we normally use, we make a 1-inch cut. We try to go past, each end to make a nice, easy cut. This allows us to get a nice vertical edge when we do that jackhammering. So, and then, the fun part, jackhammer. It's a pneumatic hammer. And and I said, sometimes the concrete's easy to remove, others it's not. I mean, you have different, the crews are pretty good on how to handle it, whether they need to put more pressure into it, whether they can, they're pretty good at that. I mean, I don't do a whole lot of jackhammering. I've done a couple, but it's not fun. Let's put it that way. This is kind of what happened. We have like vac trucks. I know on the slide I showed earlier, there was, if you don't have a vac truck, this is what you have to do. You have to pile these up, and it gets kind of tedious. And this is a situation where, we had a deck patch where we thought, it was kind of, not deep, and then it turned into a full depth at certain parts of it. So, like I said, it's hard. It's hard to dictate what type of patch you're going to do until you're out there actually doing it. So, so just beware that you can do either, you can do a combination of them if that ends up that way, A lot of times when we go out there, we want to make sure that they get all the material out here, because obviously this, area where that box is and all stuff, that's loose material. And when you pour the new portion of the deck, it's good. It's not going to be sound there. So we always try to ensure that we chip out all the unsound material around it. This right here is a situation where we always check the edges. You can see that along that edge, there's a gap. This one here, I think is a shallow overlay on top of a deck where it started to debond. And unless you have another method, which we do, sometimes we do deck ejections. This is what we're trying to fill, is that gap there. That's a different process and a different presentation, but unfortunately, you're going to need to go farther out with your patch. So, because I said, when you have that gap there, that's where where it's going to fail. So technically, the patch would need to go a little bit deeper or wider out, or a bigger patch there. Again, we do have sweeper trucks that have vac stuff on there. This makes life a lot easier when you have something that can suck this up, because again, pretty much if you don't, you got to use a hoe to get all the as much of that out there. I've seen sometimes on job sites, I've seen kids just sit down in Indian style and just pick out all big chunks out of there. So those are all methods that you can do if you have on there, but it's nice to have some kind of sucking to really get everything out of the patch. And then once you have most of the big stuff, and like I said, we have ways to vacuum that out. But if you don't, this is where it gets messy. You know, you gotta blow out all the area here to get as best that you can, the area as clean as you can prior to sandblasting. So once you get that out of there, you then can come in there with a sandblaster and blast the steel. And we like to blast along the edges and, you know, anything, especially around the edges on there. You know, I'm not too worried about the underneath the steel, but, you know, obviously when you do the steel, you're probably going to get most of the concrete on there, but a lot of them will forget about the edges, and the edges are very important because that's where, you know, that helps bond the concrete to the good concrete that's already out there. So, and then, so once you blow it out, you sandblast it, and then you got to blow it out again to make sure it's fully done, and then it should look like this. So here, obviously, we've had to add some reinforcement. So, you know, they know how to lap, you know, so they go ahead and they do a lot of you know, a lot of that there. This is a situation where we had a full depth. So, you know, and part of the full depth patching there, you know, we want to make sure that, you know, that all your edges are really good, and the surface is all good concrete all the way around there. And when they start doing the form work, you can see that there was, you know, area where it can leak, and where, you know, we like to have better form work. So this is an example of a bad form work. They should have a bigger you know, piece of wood, you know, to go over that area there. Here's an example of a good bracing. You know, these are, you know, some crews are really good at bracing. Some I have to kind of work at a little bit. But this is a situation where they did a good job on bracing this. So, as I said, a lot of times when you pour that concrete, if this brace is moving, or if, you know, any type of vibration or anything, will start causing some of the cracks that we have on there. So, this here's the situation of a finished patch. As you can see, you know, pretty happy with it. Most everything looks pretty good. I mean, there's a couple of these spots here. It'd be interesting to see how thick they might be able to combine a couple of these patches. You know, the only thing that they're missing here is the anodes. So we always try to get them, you know, especially when we do a deep or full depth. We want to put anodes. The shallow patch, you don't necessarily have to put anodes in there. We have a special concrete for that. But this is kind of, you know, the anodes that are placed in here. The bottom part of it, I don't think that's hooked correctly. So I wanted to show it. That's all hooked to one bar. Typically, you like to hook to two different bars. So you just don't put the anodes on one bar and that's it. So I think that's,
Yep. So, all right, you get to listen to me rant about materials. So like, oh, let's see here. Laser point. I know. Good fancy.
oh, you get the answer. Oh my goodness.
All right. So as Jacob mentioned, we try to break it up into 3 different categories of patches: shallow patch, deep patch, and full depth. The shallow is above reinforcement. With the shallow patches, you're limited to non-traditional concrete, which is like a chemical concrete. Our state, we generally use T17. We've used a product by Quick Bond Polymers. Echem has a different one too. There's a bunch of different manufacturers. Generally, they're non-water, non-cementitious materials. And what they do is they bond with the surface of the concrete versus traditional concrete like the deep patch and the full depth. They really, well, they do bond with the concrete surface a little bit. They primarily need to be held in with the bar. So with those concretes, with those types of patches, you can use anything in the shallow category. Now they are a little more costly, so you be mindful of that. But we generally stick to a product called 1060. It's a rapid set mortar concrete, traditional 4500 concrete ready mix, or we even use latex concretes. So yeah, I think that was it. Oh, I have one more. Oh yeah, here it is. So the standard concrete materials, when you try to go shallow above reinforcement, it doesn't resist the shear forces in the material enough. So as the bridge deck deflects, the bond will fail of the normal concrete. That's why you need the chemical style concretes like the T17 and such. Getting to the material selection. So you've already decided, what style patch you've saw cut, you've chipped out, you've removed everything, and you're down to sound concrete or full depth. Now you need to decide what type of cure time do you need. Is this an area that you have to have traffic back on? A lot of times in Michigan, we are given 9 to 3 closures, and that's all we're allowed to have. That generally means we have to spend more money and use rapid set concrete. Like I said before, the 1060 by BASF, it's now SECA. It's a relatively conservative number, but we tell the crews about 2 to 3 hours, open up traffic. We have test results. We get about 4,500 PSI in that range. Like I said, Castec, the T17, this is made by Transpo. They're generally 2 hours. We've seen strength, as little as 30 minutes. These other types are very similar. Laundry cure times, that will be your standard 4,500 concrete. We call it 4,500. That's the PSI strength. Our spec requires 4,500. A lot of our crews, we have shortened that mix design cure time, and we have test results that have shown 3,500 PSI in a couple of days, and those regions have felt pretty comfortable to opening up the traffic within that time. It does say our spec does call for a 7-day wet cure. That would be the burlap soaked in water for 7 days. And then the latex concrete is 45-hour wet, 48-hour dry. Getting into the prices a little bit, the rapid sets are, anywhere from the 1060s, generally about $500 to $1,000 per yard. The T17 is upwards of $4,000 per yard. And then your standard 4,500 concrete would be about $200 a yard for comparison. I think that's all I have. Go ahead.
Tom, I have a question that came in. What is your impression of the longevity of the patches between the rapid cure mixes and the standard mixes? Is there a difference? One better than the other?
Yeah, so generally I'm always going to be in favor of concrete. If we can get out there and get the cure time, that's going to be the best case scenario. A lot of times we don't have that. We have a freeway bridge where I-94 in Michigan, we got to have traffic back on it. That's when we'll go with the rapid set, which is more like a 9-sack or an 8-sack mix. It's very hot, so your longevity is shrunk, but what you gain out of that is the quick turnaround. So when we do see the patches, they don't last quite as long. I'm talking in the range of 10 to 15 years. We have cars on them right away, and that's the price we pay. We want, safe passage as soon as possible. Does that answer the question you think, Jason?
So if you're a local agency with a low volume road, you would highly recommend just sticking with a traditional concrete mix?
Yes. The only thing you would be mindful of is if you have a low quantity. If you can't justify having, a lot of times now the ready mix trucks.
That's a good point.
A short load is 3 yards. So you're paying for 5 yards when you're only getting 3. That's when you could use the bag stuff. The 1060 comes in, you can buy it in a bag. A T17 comes in a bag. All these rapid set, and you can mix them in a bucket. It's very user friendly. All you need to go to the job is a pickup truck with the material and a Jiffy mixer with a mixing drill. So that would be another time where you would want to use one of the more expensive concretes.
And also, just to add on if you have a patch where you're not going below rebar, then you can't use, this. So that's I said, it depends on, the prep time they want to have out there and how sound the deck is, So
even going back to this slide, if you have sound concrete, and it's a shallow patch, but say you don't want to pay for the rapid set, you would have to hammer bull bar to have, traditional ready mix concrete. Like I said, they just do not stick very well without having the reinforcement to hold it there. So we've seen quite a bit of failures by rapid set concrete. Another example is, say in this patch, we only have 2 bars exposed. So our cutouts like this, and this is shallow. If you used ready mixed concrete, this would delaminate a lot quicker than the rest of this. You need to be below bar on the entire width of the patch shown here. So
traditional concretes have to go below bar, and those other fast sets have either bonding agent built in, like they're a sticky mix, or they have a bonding agent applied to the surface.
yep.
Okay.
Yep.
Thanks.
So yeah. So I think that was pretty much. Yep. So talk briefly about some of our patching materials we use. This is the BASF 1060. Like I said, it's now owned by Sika. This patch, we do use some portable batch plants. They're trailer mounted configurations that have a sand hopper, a cement hopper, and a water container and an aggregate container, and they mix in this auger. This allows us to do short loads. We have material on hand. We could batch, I don't know what it is, 4 yards max at a time. So here the crew is, they just went out there, hammered out this patch. It was probably an emergency area, and they were able to pour the same day. They were not limited to calling ahead, ordering the concrete, waiting for the concrete, in a ready mix truck. They had this built in. Here is just a quick glance at the TDS. It's a Master Emco T1060. Like I said, it's now owned by Sika, I believe. It's a one component, shrinkage compensated, very rapid setting cement based mortar, the technical name for it. We mix, there's 3 different styles. You could purchase it as just a concentrate cement, which you would have to add the sand, the aggregate, and the water. You can purchase it as in a bag form, like a 50-pound bag that comes with the cement in it, the sand in it, and you would have to add the aggregate and the water. And then you can also buy it as the most simplified version is has everything in it, including the stone. That is the least cost effective because you're buying the stone, which is a cheap material you could generally purchase locally, but it is the easiest. You grab a bag, you dump it into a bucket, and you mix it. It's very simple. Here's the same mobile mixer again. Like I said, we have 3 of these. They all pretty much are ready to go at any time, especially in the winter, say 35 to 50 degrees. We store these inside. They have tank heaters built into them for the water, and they're just ready to go. We never know if we have an emergency on, one of our major highways, and the crews need to get out there right away and patch. So the top hopper holds the ready mortar, or the front hopper near the water tank. I'm sorry, the back hopper holds the cement mix, and then the front hopper is 2 sides, left and right, one's sand and one's aggregate. Once it's started, those materials drop down onto an auger belt and auger slowly into the back auger, the dispensing auger. And once it hits the dispensing auger, that's when the water is added, and it mixes. It's fully mixed once it reaches the end of the chute. So, like I said, we have 3 of these. This is our oldest model. We have 2. I think they're cement techs, more trailer mounted style, but we use them quite frequently, mainly on our more busy metro areas, but they work well. Here's an example of the T17 being applied, or I'm sorry, the 1060 being applied. This is a very fast setting concrete. You hardly have time to work it. A lot of guys will like to try to get a beautiful finish, and by the time they're halfway done with the patch, the other half is set up. So you need to screed it off quick, and you just need to be quick. Like I said, open to traffic in 2 hours. Really, it's a 15-minute max working time. You got to get it into the hole and screed it off and smooth it out as best as possible.
This was probably done by a bucket or by a 5-gallon pail because it's just a small patch. So these are this is
and this is how a lot of the rapid set concretes are, whether it be the chemical based like the methacrylates or even this hotter cementitious mix. Get into the T17. This is an example of a beautiful patch preparation. Nice square edges, all saw cut. You could tell the surface was sandblasted. They had one exposed bar. They were not below it, so they did want to use the T17 where instead of hammering to below bar. They also, to note, for a lot of these that have like a primer that goes on prior, you want to sandblast the edge because you want to have primer, whatever bonding agent to the substrate. You want to have it on the vertical edge as well as even a little bit, like a 1-inch overband around the perimeter. It really helps with the bond of the concrete. Here's the data sheet quick. One thing I wanted to note, not all of these rapid set mortars can be used in a colder temperature. Michigan, we have very cold weather, so we have had put this material down to 14 degrees. That's one of the reasons we have it here. I know the Mackinac Bridge, they have to keep open at all times. This would be a good option if we had like a failure in that area. The crews could mobilize and go down to 14 degree versus normal concrete. You would be limited to freezing temperatures. Yeah, so I think that's all I had there. Kind of got some walkthrough instructions of placing the T17. One thing to note, the guys are putting on the primer right now. You can see right here, he's painting it over the edge a little bit. This is a very good practice. Yeah, about 1.5 inch or so. You want to fully encase the rebar. That's always a good practice. Everything in the patching area you would want to use the primer with. Now here the guys are mixing the resin, measure it out according to the manufacturer's instructions. Add the, this version has a BPO, like an accelerator. I know Quick Bonds is similar. All has to be measured out. We purchase a lot of these little containers that have the measuring readings on them. We generally pour the liquid into the bucket first, and then as the guy is mixing with the Jiffy mixer, we'll pour the powder in there, and then the aggregate too. This generally goes for all the concretes. You generally want to start with your liquid, pour your cement in there as you're mixing, and then pour your aggregate in as you're mixing. You'll find that generally goes a lot better than. You don't want to add all the powder, add all the aggregate, and then add the liquid. It's going to be tough to mix.
Just to give you another thing, there a lot of times you have one person doing the measurement, one person doing the stone and the aggregate, and one mixer. So you can really do this with 3 guys, out there. So,
yep. So some more instructions. The guys had the surface primed. We were told to. Surface needs to be cured. Once the primer needs to be cured before placing the patch material. But here you can see the guys are placing it into the hole and screening it. Another guy's screening it off. Patch looks good here, and here's the finishing touch. You can see the guy with the thermometer. It does get pretty warm, but like all concretes, it is a chemical reaction, so it will heat up.
Open the traffic in 2 hours.
Yep, open to traffic very quick. We've had pretty good results. I know a lot of the Midwestern states use either this or the Quick Bond material. We haven't used a ton of the Quick Bond, but I do know other states really like it. Get into patch installation, material placement. This is just a cover photo. This is a ready mix truck. Guys, pour the concrete. You want to, when possible, you want the concrete truck to do the work. They have their chute. Generally, they spread the concrete evenly. Most of the time, the operators are fairly good. That will help You don't want to put all the concrete in one spot and the guys to have to overwork pulling it and moving it to the rest of the patch. Especially on a hot day, that'll tire everyone out in a hurry. So generally you want guys finishing in or filling in the holes, guys lightly vibrating it, not too aggressive, and then guys following with a screed board or a roller screed, something in that nature, finishing, and then generally you want your bowl flow. So another picture, this is the one I was thinking of for the question of the shallow overlay. This was actually a few weeks ago. We ran into a similar situation. Shallow overlay was debonded once we removed the HMA. I don't know the numbers on what percentage of this, but once we opened it up, we kind of had to put back. So we were going to place HMA back over this, so the surface didn't matter, but I wanted to emphasize here, I had thought of this while we were out there. If you were to do patches over the center line, which your crown is generally in the center line, you want to make sure to screed the concrete to keep the existing roadway crown. Like I said, with this situation, we are going to put HMA on it so we can establish our crown there. But if this wasn't going to have HMA on it, you wouldn't want this to be flat across the surface. You want the bridge to drain as it was designed, which in this case would be to the edge and then off the bridge. So another thing to note on this as well, whatever screeding method you have, you want to make sure that it's wide enough for the application. We ran into some issues here. We had, I believe it was a 12-foot roller screed, which this is clearly wider than 12 foot. So we had to anchor one point here and kind of wet screed across, which is not the best practice. It's very easy to have poor grade, low, high spots, you name it. So just a best practice. That was on our side. You know, we should have thought a little bit more ahead and done it that way. Other than that, this was a fairly good patch. Another thing to mention, in the scoping process, if you have construction joints in your deck, these are generally, at least in our state, they're hot poured rubber, like a cold joint. You want to reestablish those in your patch. Generally, you could just use like a thin piece of rubber, something to either leave in there, or you could saw while the concrete is still relatively fresh, maybe one day in. You want to reestablish because the bridge it was designed to flex at that point. So you just need to make sure you reestablish all previous joints in the deck. I know this one, we went over one and it will crack at those points. So another patch installation best practice. I'm not an expert on finishing, but the guys have told me, the veteran guys, you want to finish from the inside to the out. What this does is it helps push concrete to the edge instead of pulling it away. When you finish from the outside in, it pulls from the edge just slightly, and that's just another area for water to enter, water, chlorides, you name it. So you want to try to push it out. It's just a best practice. Here's another schematic of that, kind of referring to what I mentioned. So yep, finish to the edge. I do want to mention here too, take note of, generally on patches you want a broomed finish or a tined finish, whatever your existing deck condition is. I know in our state we do our tining transversely. That is primarily for drainage, like I said, to get the water to shed as the bridge was designed. So we tine transversely. So as we patch, we want to try to get those tines reestablished. Curing. So generally, you want, the best practice is the wet burlap. This is like a burlap fabric that is soaked and applied to the deck to help slow down the hydration process. You're going to get your best quality patch the longer you let it hydrate. So this is what our spec shows for all our new concrete. That 7-day wet cure I referred to, that is the deck being saturated for 7 days to help slow down that hydration process. Another curing practice, heating and housing. So as I mentioned, we're in the cold environment when you cannot let the concrete freeze once it's cast. In this situation, I believe it was around 40 degrees, but the crew was just, they wanted to keep the concrete relatively warm. So this is one of their makeshift heating and housing. You could see they have a salamander going. You don't want it to be too warm, but you also don't want it to get too cold. So there are other methods, more efficient methods, like there's electric heating blankets. They sell them in all different sizes. Most of our crews have those on hand for this type of stuff. A lot of times, if it is cold weather, they can preheat the top of the deck, the bottom of the deck. You want the substrate around the patch material to be warm. You want it to all be similar when you go to cast the concrete. I think that's all I had there. Anything? And then Jacob will take over.
Well, I guess based on time, do you want? I can hold off on this part of it here. These are just.
You there, Jason?
You there, Jason?
Yeah, I mean, how much more do you have?
I just got a few more slides, but I mean, these are just deck preservation practices that we do. We try to force the crews to do cleaning.
I would definitely like to see the best practices.
Okay, so the cleaning the bridge, siling is something that we try to force our crews to do as much as we can. That's stuff that you got to reapply every 5 to 8 years. We do siling with a healer sealer. A lot relates to the reason why we use a healer sealer is that it heals the concrete versus just a sealing. There's some products out there just they seal it, they don't really heal it. And then we do a lot of thin epoxy overlays. For that.
They use the arrow with the fancy pointer.
How do you do that? This is, like I said, part of the way we clean it is that we have sweeper trucks, like I said earlier, where they go out there to sweep it, and then sometimes we have guys along the edges because that's where a lot of deterioration happens along the barrier there. So we have crews that do several things like that. All the surface washing, this is part of especially like the movable bridges that we do. Those we do every year because they have a lot of steel grating, a lot of steel parts, so we want to make sure we wash it. And because of that, it's actually we prolong the life of those bridges. So the rest of the bridges we try to get as many as we can, so we have the crews do a lot of washing. Expansion joints, obviously, if you leave debris in there, that's where the glands get torn and all stuff. And once you tear a gland, you can replace it, but it's very difficult. And if it gets too torn to a point where you can't replace it, you have to replace it by expansion joint device, and those are very costly. So as much as you can clean the joints out of the bridges, they will make your bridge last the longest. So silane, this is kind of how we apply silane after, especially when we do a healer sealer, we apply that. And we've actually been doing some with epoxy overlays too, the thin epoxy overlays. So it's just an added protection. This is an easy method to do. That's a whole new presentation on something. That's our healer sealer operation. Like I said, we have a bunch of equipments. We've got 6 or 7 of those, I think, units throughout the state that apply the healer sealer. That's again another presentation. And then thin epoxy overlay is it's a 2-layer method that helps preserve the deck. So that's about it.
All right, if anyone has any questions, please type them in the chat and I'll relay them to Jacob and Tom. And Jacob and Tom, thank you very much. That was awesome.
Well, we did pretty good on time, looks like, about 45 minutes. So.
Yep.
Yep.
Somebody wants to know how often you apply sealers. So I would just high level, how often?
Silane, we would recommend like 5 to 8 year mark. Now the penetrating epoxies, like we call it the healer sealer, a lot of our areas are on a 5-year cycle. We like it 5 to 8 years to reapply. That'll either be from new cracks being created, or some of the epoxy maybe the crack opens more than the epoxy can handle, and so 5 to 8 years generally.
It also depends a little bit on ADT. The higher the ADT,
Right.
the more likely you might need to be closer to the 5. If you have less ADT, you can probably get away with 10. I mean, especially if you put a silane and a healer sealer on it.
Yeah,
I
this
think
is a
that's
local county bridge, dirt on both sides, then you could probably get a lot longer. But if you're on I-94, or 75 in Michigan, you're not going to see it's quite the life.
Oh, they're just coming in fast and furious now.
No.
Do you recommend silane or epoxy healer sealer, or a thin epoxy overlay?
So generally, our
For
best
longevity
practice now is both.
Mhm.
If we're out there doing a healer sealer, we require a shot blast of the deck, which is abrasive blasting to mainly clean the deck, to open up the cracks a little bit. So if we're already there, we like to put the silane down. The prep work is already done. The silane is just one extra relatively smaller cost, and a short cure time. You could be a lot of times back on it in an hour to place the epoxy. It just depends on the area. If you don't have the shot blasting equipment to do the healer sealer, silane is your next best. The prep, a lot of the manufacturers, all they recommend is a power wash. So that could be a good option too, especially for the local agencies. Very cost effective. You could buy the pump up sprayers and a power washer and be out, silaning your decks. That'd be great. So.
When and why do you use galvanic anodes?
So galvanic anodes are a form of passive cathodic protection. You would want to use them on a deck you want to keep in good shape. You would not want to use them on something that already has epoxy coated reinforcing steel, because you would be compromising the coating to put it back on, unless it was wore off. Generally, we like to tell the guys, if this is a newer deck, a good deck, say we're at year 10 of the life of it, of a 50-year life or a 75-year life, we want to keep it in there. Cathodic protection, it's a hard Kool-Aid to drink for the guys, because you can't see it. It's hard to see. The best way I can describe it is, every water heater in a house has an anode built in. The water heaters generally have the warranty for 10 years, which is usually the life of that anode. If you go and look at the water heater after 10 years, that anode is down to nothing, and that's when your corrosion starts. So really, you're just going to delay the corrosion starting point. So we like to use it on our higher quality stuff. If we know we're going to replace that area in less than 10 years, cathodic protection might not be the best option. They are costly. It's a lot of maintenance, and it's hard to monitor the performance. So.
Okay.
Yeah, and like I said, if you have like a T17 that's considered an impermeable concrete, that's why you don't normally use it on a shallow patch, because it would actually defeat the purpose.
Yeah, that's a good point. You'll have to look at the different concretes, but a lot of the concretes, especially the chemical style like T17, UHPC is similar. They're very impermeable concretes. Like Jacob showed in the one slide, concrete is a sponge. It takes on water. It will take on water unless you have certain additives and a different mix design. So, but if you know you're going to use these other concretes, cathodic protection you don't need it, because the concrete will not take on the additional moisture.
All right. Just looking what I saw. Do you have any recommended procedures for overhead patches?
No.
Okay.
Yeah.
That's how I
mean,
answered
we've-
it earlier.
I mean, we've done a lot of 1060, but you have to, again, 1060 is it's a rapid set mortar mix. It takes a very little amount of water, and you got to make it where you don't use as much water, and you can get it to where it's sticky, but yet solid. So, I mean, we've done a lot of culverts like that.
Yeah, and we've experimented. We've done some unique things. We're not sure on the performance yet. But like an epoxy grout, where we would form up the bottom of the, chip out, scale the concrete on the deck bottom, form it up, drill holes through the top of the deck to basically funnel in an epoxy grout into that patch area. It's very challenging though, because you're not going to know your consolidation. You have no access to it. Your best bet is to have enough head pressure to push that material into the void down below. And then once you strip your forms, it's going to be set up. So you really only get one shot. And so we're still evaluating the performance of that, but that's really the only thing other than a full depth patch for overhead.
Okay. Well, thank you again so much. That was awesome.
Yeah, thank you, Jacob and Tom. That was fantastic. I was going to mention that there was a few questions on whether or not this presentation would be made available. I did put a link in the chat where all the local agency trainings have been stored, so it'll get uploaded there in the next week or two. Yeah, and thanks again. That was fantastic.
Absolutely.
All right. Well, I guess that would conclude this month's webinar.
We didn't lose too many people during the presentation, so
You didn't
Couldn't have been
lose
too bad.
anyone during the presentation. That number stayed at the same number the whole time. So